Hi there, welcome to this Maths Tech 1 Outcome 2 lecture. This is the second one on drawing trig graphs. So we're going to now look at leading and lagging angles. So if we have an expression such as y equals sine x plus 30, this is called a leading angle. It means that it starts the wave early by 30 degrees. If you have an expression such as y equals sine of x minus 45, this is called a lagging angle, and it means it starts the wave late by 45 degrees. So it's a little counterintuitive. So if I was to sketch y equals sine theta plus 60, normally the graph of y equals sine of theta, just for reference purposes, would look like that. However, we've got this plus 60 to contend with, so that means we have to start early by 60. Now, what we actually have to do is we have to start at minus 60 and move everything along by 60 degrees. So all these points move back 60. So the graph of sine of theta minus 60 looks like this. So sine of theta plus 60. Now it's a little counterintuitive because you'd think plus 60 you should start plus 60, but no, you're trying to compensate for this plus 60, so you start at minus 60. Okay, so it moves in the opposite direction to what it's written as. Similarly, if we have cos of theta minus 30, so just for reference purposes, the cos wave normally looks like that. So that is y equals cos theta. So cos of theta minus 30 means we're going to shift everything 30 in the other direction. So instead of minus 30, we're going to start plus 30. So everything is going to move 30 degrees along. So it's going to look like this. And then just make sure it comes back down and just starts to join up again. You don't want a little gap there. So that is y equals cos of theta minus 30. So it always moves in the opposite direction to what it's written as. So if it's plus an angle, it's going to move to the left. If it's minus an angle, it's going to move to the right. Okay. So in general, for any graph of the form y equals k sine of nx plus a, and this works for cos as well, amplitude is k, period is 360 over n, and the lead angle is a over n, or the lagging angle is a over n, depending on whether it's plus or minus. Okay. So what I mean by this is if we have something slightly more complex looking like y equals 3 sine 2x plus 30, this is combining all the different parts. So we've got the amplitude of 3. We've got the number of waves being 2. And then we've got the phase angle being 30. Now, when we've got a different number of waves, to calculate the phase shift, what that's going to be is it's going to be the phase angle 30 divided by the number of waves, which is 2. So we get a phase shift of 15. So it's this number here divided by this number here. Okay, so it's not going to start at 30, it's actually going to start 15. And we're actually going to start minus 15 because it's plus. Okay, so we now need to draw that graph. So that's minus 15 there. Okay, and we need to fit 2 waves in here. So 2 waves would normally so one wave would be between 0 and 180, but everything's shifted along by 15. and that would normally peak at 90. Sorry, come through the axis at 90, so back 15 to there. And you can see that everything is just kind of halfway at that point. So you can get away with just drawing one wave. You don't need to draw the full two waves. So that's what your graph would look like. So you've got your amplitude of 3. You've got two waves between 0 and 360. We've just drawn the first one. Okay, so your first wave will be there. Your second wave will be in that space there. Okay, and this minus 15, this is the hardest bit, comes from the phase angle, the 30, divided by the number of waves being 2. Okay, so let's do another one. Y equals 2 cos of 3x minus 90. So we've got this being your amplitude, 2. You've got your number of waves being 3, and you have got your phase angle being 90. So your phase shift, but your starting point is going to be 90 divided by 3, which is 30. So that's going to be your starting point. Okay. Now we then need to work out, are we going right or left? Well, because it's minus, we're going to move to the right. So it's going to start at plus 30. So 30 being there. Okie doke. Now it's 2 cos, so it's going to start at 2 rather than 1. And we need to fit 3 waves in there. So that means a single wave is going to be 120 degrees long. So that means it's going to finish here at 150. It needs to go between 30 and 150, which is 120. Okay. So that is going to look, it's got a single wave like so. Okay. That's your first wave. That's your second wave. Okay. Don't leave a gap at the start of an axis like that, so make sure you can connect it down. And this would then look, if you were to continue it on, that would be your second wave. Hang on, just do that again. Sketch that all wrong. Yeah, like so. Okay, so that would be second wave, and that would be your third wave, like so. Okay, everything moves 30 along. So second wave, and finally your third wave. Okay, so remember, this is the key part is the phase shift. That's your starting point. Okay, and that is done by doing 90 divided by 3, and then you just check the sign. If it's minus, it moves to the right. If it's plus, it moves to the left. Okay. Right. So now going on to Moodle, I want you to look at drawing trig graphs 2, please. Thanks very much.